Hi everyone! Today we are going to present our final project proposal, Community Detection in Social Network. We'll spend about 5 minutes to discuss our motivation, dataset, and methodology. Nowadays, we are creating increasing amount of information on social media. The various interactions between individuals imply their relation structure. A community is a subset of a network that within which each node is close to each other and has similar attributes. This method is better than other clustering algorithms, since clustering only considers attributes of nodes, while communication detection also considers the structure of the edges. So it detects underlying relationships and provides explainable insights. It has wide range of applications such as targeted advertising. For example, we can give personalized recommendations to Amazon users, Grubhub users using the communities. And we can detect suspicious groups in anti-money laundering. Like traditional AML analysis, individual client profiling gives large false positives rate. So detecting communities can help to reduce the false positives. It can also be applied to solve infectious diseases and business intelligence problems.
So next we will introduce our dataset. The main source of our dataset is from Stanford University Large Network Dataset Collection and is called Email European Core Network. This dataset contains all incoming and outgoing email data between members from a large European research institution with 1,005 nodes, which means over 1,000 people, and 25,000 ages and 42 labeled communities. And also, because we are particularly interested in the financial industry, we found a dataset for the fraud detection, and it contains the mobile money transaction based on the sample of the real transaction. And the other option of data will be Facebook, Twitter, social network dataset, and we are still finding those. The tools we're gonna use for this project are based on the class with the Python, PySpark, Hadoop, and Hive. And the algorithm we're using is the community from age structure and node attributes, which called CESNA.
So in this method, we have a probabilistic network model denoted by GVE, where V is the set of vertices and E is the set of edges. Each node has a binary valued attribute x, which is a vector. So if a node represents a person, then x can include age, gender, and something like that. Each node also has an affiliation weight, FUC, which is somewhat defined as the measurement of the possibility that node U belongs to community C. With FUC, we define the possibility of two nodes that are connected to each other using this equation, which also means the possibility that they share any common community. We also have a logistic assumption on attributes. Pay attention to W here, which is another parameter in this model besides FUC. With this model, we have a maximized likelihood optimization problem. Log here is a standard process in machine learning to discard the constant but unknown denominator. Calculate this equation, we get two terms. Then we can use solution block coordinate ascent to solve this problem. The idea is to decompose the problem into several convex optimization problems. That is, we have an initial random guess of f and w, which is close to 0 but not 0. Then fix w optimize f using any convex optimization technology like gradient descent. Then fix f optimize w using the same technology. Repeat the previous two steps until the change is small. So with the parameters in this model estimated, we can now determine the membership by setting a threshold. So we want the two nodes within the same community has a probability to be connected with each other larger than 1 over n. So we can use this to determine the threshold. We can also reserve a holdout set and then try a different number of C to find out the best value, the best number of communities. So to our best knowledge, This method is the only one that supports overlapping community pod membership and allows structure and attributes dependencies. And this is also a linear complexity algorithm, which means it runs very fast.
And here we listed our expected contributions, and we stick with the timeline before the deadline of the project. If you have any questions or suggestions, please leave your comments below this video. Thank you.